Welcome to this video in the Doing Stuff with the SSSD series. My name is Lawrence Kearney, and I work extensively with the SSSD on several Linux platforms. This video details the deployment of the daemon on a SLES 11 system against an Active Directory backend. The systems used are SLES 11 Support Pack 4 and Windows 2008 R2. I wanted to do this particular tutorial to help others understand and implement the SSSD reliably against Active Directory using SLES 11, a procedure that is not well documented. The younger YAST on SLES 11, especially for those new to the SSSD, is a bit kludgy and confusing relative to implementing this particular daemon, increasing the perception of complexity. Conversely, the YAST Authentication Client module on the more recent SLES 12 and OpenSUSE platforms is more intuitive, SSSD friendly, and package the SSSD binaries in a more conventional way. However, as we are using SLES 11, this tutorial will cover a manual deployment outside of YAST to facilitate understanding of the daemon components. We will be using a deployment checklist. We will install and configure all of the required software. We will disable the name service caching daemon. We will validate that time synchronization and DNS is working correctly. We will modify the name service switch file. We will modify the PAM framework to support the SSSD. And then finally, we will configure the SSSD itself. In the course of this deployment, we will configure 4 clients on the system. The clients that will be installed and configured on our built system will be the Linux Kerberos client, which will be used for joining and pre-authentication to the Active Directory domain. It's very useful to have it on the system outside the context of SSSD. An open LDAP client, which is again very useful to have on the system for troubleshooting purposes and just for searching Active Directory. The Samba client, which will be used for joining the system to the domain as well and will be extremely useful on the system, and we'll see examples of that later. And finally, the SSSD client itself and its providers, responders, and a couple of utilities. The Linux Kerberos client is used to connect the system to Kerberized directories like Active Directory. I install the Linux Kerberos client for 3 reasons. 1, to initially join the system to the domain and generate the system keytab file. The keytab file contains encoded credentials used by the Linux system itself to pre-authenticate to Active Directory. 2, to allow normal Active Directory users to pre-authenticate to perform tasks that require a Kerberos connection. 3, it's very handy to have for troubleshooting Kerberos connectivity issues on Linux systems. I always configure the Kerberos client manually, outside of YAST, to prevent the deployment of the PAM LDAP and PAM KRB5 modules, which would just have to be deconfigured later. There is a minimum amount of configuration required for the Linux Kerberos client. Essentially, you only have to configure the krb5.conf file. So, let's have a look at that, but first let's show you the package that we installed. And you can see we've just installed the krb5 client package. Now, looking at the original krb5.conf file, which is installed with the client, you can see it's a pretty basic template, and there's not a lot of information that's required. So, let's look at the configured Kerberos client file. As you can see, I've configured the default realm under the live defaults stanza. Under the realms stanza, I've configured the KDC, the default domain, and the admin server. There is only one DC in this Windows domain, so that makes that pretty simple, but you can point to any DC. I I've configured both cases for names and DNS formats within the domain realm stanza, and I've added an app's default stanza with the few defaults that I always use for Kerberos clients. The Open LDAP client is another great application to have on your system. It's useful for searching Active Directory to validate objects, attributes, and values outside the context of the SSSD or the MMC, and it is also very handy to have on the system for troubleshooting Active Directory connectivity issues. No configuration is actually required to start using the client on the system once it is installed. However, there is a configuration file you can use to specify defaults, which makes the command line a little easier to use. So, the configuration file for the Open LDAP client is actually the etc open LDAP LDAP.conf file, which is not to be confused with the etc LDAP.conf file, which is used for system daemons, or the .LDAP RC hidden file, which is used by users to override the system defaults in the etc open LDAP LDAP.conf file. So, that said, let's look at the defaults we specified in our etc open LDAP LDAP.conf file. So, we have specified the LDAP URI. Notice it is in the unsecure form. We have specified our search base. And we've specified the location of our certificate, which is to be used for SSL and TLS operations. And notice we have turned referrals off. Referrals are off because Active Directory returns referrals that are only meaningful to other Active Directory servers. They are not meaningful to Open LDAP systems or clients, so it's best just to turn those off. And if we'll validate that we do actually have a certificate in place in our etc open LDAP CA search directory, and in fact we do. So, our Open LDAP client is configured as well. The next client package we're going to look at is the Samba client. It's pretty straightforward to install the Samba client. You simply install the Samba package. The Samba client includes a utility called net, which is intentionally similar in functionality to the Microsoft Windows Net utility. It's used on the Linux system to join domains, manage key tab files, interrogate Active Directory for information about users and groups, to name but a few use cases. It is also deployed manually outside of YAST to prevent the full deployment of Samba and the Winbind modules, which again would simply have to be deconfigured later. The only configuration file we're going to modify is the etc samba smb.conf file, and we're only going to add a few directives. So let's have a look at that. The only directives we've added have been to the global stanza. We've configured the work group as DVC, which is the short name for our Windows domain. We've set client signing to yes. We've enabled the client to use secure protocol negotiations. We've set the Kerberos method to secrets and key tab. And we've set the realm to the fully qualified name of our Windows domain in uppercase. It's very important to know that for both the krb5.conf file and the smb.conf file. Case matters when you're specifying the Kerberos realm. And security has been set to ADS. And those are all the additions or changes that are required. The configuration of the SSSD client will come later on in the tutorial. However, I did want to show you which software packages were installed. You'll notice we've installed the SSSD package, which contains the daemon the SSSD providers and the SSSD responders, and more on what providers and responders are later. And we've also installed the SSSD tools package, which contains tools and utilities for managing, for instance, the local SSSD cache, which I find very handy and I deploy on all systems I deploy the SSSD on. So we have completed the first item on our checklist. That wasn't so bad. Now we're going to disable the name service caching daemon. Essentially, the name service caching daemon caches session-level information about users and groups. Since our SSSD daemon will also be doing that, if we had two daemons caching information for users and groups, it would lead to unpredictable authentication and search results. So it is undesirable, so therefore we're going to stop the daemon and then subsequently disable it. And as you can see, this command is going to do exactly that. There we go. Job done there. Another item off the checklist. The next item on our deployment checklist takes us to time synchronization and domain name services. Because time synchronization and namespace services are very important in Active Directory and Kerberos environments, we'll be spending some time here. Our Windows Domain Controller is used as the time source for our SLES server, and that domain controller uses a remote time source itself. So let's have a look at that relationship. So we see our Windows Domain Controller, and we also see its remote time source, and the time stats look pretty good. So we're all right there. Let's make sure that time is synchronized on our SLES server with our domain controller. And in fact it is, so we're good there. Time synchronization looks good. Turning to our DNS configuration, let's look at our host file. You see, we have a fully qualified name for our Linux server. And let's look at the local resolver configuration for our SLES server. You can see that our intention is to participate in the same namespace as our Windows domain, and that we are pointing to our domain controller as our DNS server. So let's look up some DNS records. Let's make sure our Linux host resolves and our domain controller resolves. Fantastic. Our domain controller resolved successfully. Let's look at our Linux host. Fantastic, that's resolving as well. Let's now look up some key Active Directory SRV records. And we'll start with Kerberos. Our Kerberos SRV record looks up successfully. Let's try LDAP. Fantastic. Our LDAP record looks up successfully as well. And just to be thorough, we'll try the global catalog. Brilliant. That works as well. It's important to understand that in order for service location for the SSSD to work successfully, that the DNS configuration for your Linux server has to be in good working order, as ours appears to be. Configuration of the Linux system to participate in the target Active Directory DNS namespace is best practice, especially in the context of service location, but it is not required for a properly configured system. And we'll show you how to configure your system for a different DNS domain for service location later on in the tutorial. Well, we are now at the point where we should be able to join our SLES server to our Windows domain. However, because our system should now be able to interact with Active Directory, we're going to exercise some of our configured utilities first, starting with the net command. Let's first see if we can learn anything about our Active Directory environment. In fact, we can. We can see our server address and name, specifically our domain controller. We can see our realm value, which is, notice, is in uppercase, our search DN, and our KDC info and some time information. So that looks great. Next, let's exercise our LDAP search utility a little bit. And the first search we're going to do is going to use certificate-based services and a forced TLS connection. And I know this command line is a little busy, but we're going to walk through it. The ZZZ argument will force a TLS connection, and if the LDAP search application is not able to connect using TLS, it will simply fail on the command. -X is forcing simple authentication, meaning we'll have to use credentials, specifically a username and password. And you see our proxy username here, and we're specifying to prompt for the password with the uppercase W switch. And we're also specifying our search base and the object to search for, which should be an existing computer object in our Active Directory environment. We are prompted for the password. And in fact, we do get a successful search. We do in fact find our object, and it is in fact a computer object. So great. Let's perform the same search using SSL, now that we know we can use TLS against this backend should we want to. And you'll notice it's basically the same search without the ZZZ and without the host declaration, which is needed with the ZZZ switch as well. And we do get a successful search once again. For our computer object. So great. The next search is going to be performed using defaults which are specified in a .dot file in our user's home directory. Now, similar to the way that the .bashrc can specify defaults for a user's bash environment, a .ldap-rc file can specify defaults for a user's LDAP client environment. And the settings or the defaults specified in the user's .ldap-rc, as long as they are in the user's home directory or in the user's path otherwise, will override the defaults specified in the etc open LDAP file. The main difference between the .ldap-rc file and the open LDAP file is that you can specify the bind DN in the .ldap-rc, whereas you cannot in the open LDAP So let's have a look at that file first. Noticing that we are in our user's home directory. And you'll notice that the defaults are the same in this file, except for the fact that I can specify the bind DN, which will shave quite a bit off of our command line. We still have to specify simple authentication. That is what our command line has been trimmed down to, and it should work. And in fact, it does. Brilliant. So, The other thing you'll notice that, of course, this is a lot of information. And if you're looking for all of it, that's fine. But if you just want to trim it down to more meaningful responses, you can, of course, use the standard Linux grep utility to do so. As we see here. Very good. That's a little easier to look at. I can see my object class, my distinguished name, my SAM account name, and even my service principal names for this computer object. So at this point, we're actually going to use the Kerberos client to see if we can authenticate against the Active Directory environment, and we're going to do so with an account that has privileged credentials to join systems to the domain. So let's do that, and of course we'll be validating if our Kerberos client is working as well. So we're going to attempt to authenticate as the user domain join. Oh, it's built the UPN from the realm information in the Kerberos client configuration file, which is exactly what it was supposed to do. And it looks like we have successfully authenticated. Let's verify that we do in fact have a Kerberos ticket. And indeed we do, with our domain join UPN. Now that we have a Kerberos connection, before we join the domain, let's see if we can ask Active Directory for some Active Directory specific information. So let's do a search for users using the net command instead of the LDAP search command. Very good. We found several users in the Active Directory environment that have LDAP in the name. So let's actually see if we can look at the object properties of one of these accounts. And for that, we'll use the search capabilities of the net utility. And we'll search, similar to the LDAP search utility, we should specify an attribute to filter on. There we go. We'll use the SAM account name attribute. And we do, in fact, get a great deal of information, so our search was successful. That is pretty handy. Let's perform the same task for groups in Active Directory. So we'll search for groups that have domain in the name, of which we found several which are obviously Active Directory groups. So let's see if we can refine that search a little more and get some member information. So once again, specifying the SAM account name of domain admins, and we're just going to grep for member. Fantastic. We did get member information. Again, that is very useful to be able to do from the Linux Server Console. And finally, to joining the domain, which we will also use the net utility and our Kerberos connection for. You should certainly be observing how useful the net command in the Kerberos client can be on a Linux system in an Active Directory environment. So there we go. Fantastic. It appears we have joined the domain successfully. Let's dig into that just a little more. Very good. It would appear that our join was successful. We can even use the net utility to examine the contents of our system keytab file, which was created when the system was joined to the domain. And there we go. So we've joined the domain successfully. We've been able to search it and do a lot of interrogation against the AD backend using the net utility. So let's go ahead and drop our current Kerberos connection and see if we can authenticate to Active Directory using our newly joined computer object. And we'll specify -K to make sure that it specifies to use the keytab credentials for this Kerberos principal. Oh, very good. It looks like we got a successful response. Let's verify that. Very good. We do have a Kerberos connection with the Kerberos principal for our newly created computer object. So let's do something different with the LDAP search. Now that we have a Kerberos connection and we're capable of using the security of our computer object, we should be able to invoke the SASL GSS API layer of the LDAP search utility by simply not specifying bind credentials or using simple authentication methods. More simply said, if we simply invoke the LDAP search with no arguments at this point, we should actually be able to perform a successful search using our Kerberized connection and using the security of our computer object as the proxy user for the search. And it should be that simple. And we have a successful search. Fantastic. Notice we have in fact found our computer object and that the LDAP search utility did invoke the SASL GSS API layer because there was a Kerberized connection available using the principle that invoked that connectivity. Let's go ahead and tear down our Kerberos connection before we move on to the next sections. I hope that has demonstrated the value of all of the configurations and clients that we've put on the system so far. We now have a very purpose-built system that can interact with Active Directory very well. We'll see you on the next task. Our next deployment task will be to modify the name service switch facility to use the SSSD to resolve user names. And we do that with a very simple edit to the etc nsswitch.conf file. We're simply going to add the SSSD to the password and group resolution methods. And that is all that is required for this. we're now going to modify the PAM framework of our Linux system. Let's first have a look at how PAM is configured to allow users to authenticate to our Linux server. And we'll do that with the very useful PAM config utility. Well, we can see that our local authentication method is in fact enabled. If we look for LDAP, it is not configured as an authentication method. Neither is Kerberos. Neither is WinBind. And neither is the SSSD. Now bear in mind that if we had used YAST to configure the Kerberos and Samba clients, we would have to disable the LDAP, Kerberos, and WinBind methods here in all likelihood. Well, let's look at one other service. The make homedir is the PAM facility that will create home directories for remote users that log into a server for the first time. That will become important in a moment. So let's go ahead and add the SSSD service. And let's go ahead and enable the make homedir as well. So for our use case, when SSSD enabled users log into this system, we do want a home directory created. So let's perform our query again. We do see that the SSSD is now enabled. As is the make homedir. And notice it's only valid for the session PAM configuration. And that makes sense because the action is only going to take place on a user login event, which is technically a session. Let's have a look at some of our PAM files and just see what has been modified. So, if you notice, we have quite a few files in here. The ones we are interested in are the Common Account PC, Common Auth PC, and Common Password PC. So let's have a look at those. Notice we still have our local authentication method, and the SSSD method has been added as well. Let's clear this screen up a little bit. Let's look at our auth. You can see the same here. Our local authentication method is still valid, and our SSSD method has been added as well. And importantly, one very nice aspect of using PAM config is that it will allow you to safely modify your PAM files. You could very easily render your system unusable modifying them by hand unless you know what you're doing. And PAM config will actually perform a backup of any files that it modifies so they can be rolled back quite easily. Our final deployment task is the configuration of the SSSD itself. However, first I would like to review the architecture of the SSSD software stack and how to access the system man pages for the components that make up that stack. So, let's learn to speak SSSD. I've prepared a text file that has some key information in it for us, so let's bring that up. The SSSD monitor itself is the SSSD daemon and is also a parent process. Its functionality is similar to that of the init daemon on System 5 Linux systems. More on this in a moment. SSSD providers are modules that process configuration directives specific to that provider. Provider modules are usually named for the protocol or service they implement, such as LDAP, Kerberos, or AutoFS. SUSE packaged the SSSD providers for the SLES 11 platform a little differently than other distributions. The majority of the supported providers are included in the SSSD package itself. Additionally, the SSSD Active Directory provider is not included on the SLES 11 platform. SSSD responders interact with providers and the Linux system components to implement SSSD features, similar to a software gateway or a bridge between them. The monitor daemon monitors the statuses of the responders. If a responder crashes, the monitor restarts it. All SSSD responders are child processes of the monitor process itself. SSSD authentication domains are collections of provider directives used to connect to an authentication backend. Each authentication domain is a standalone configuration, and the SSSD can implement more than one concurrently, enabling it to use multiple authentication sources. More than one provider type can be used in an authentication domain, or the same provider can be used in multiple authentication domains. Authentication domains have unique open-ended names. It makes sense to choose meaningful names. The exception is when the authentication domain uses the Kerberos provider, as is the case here, or the Active Directory provider. In these cases, the name of the SSSD authentication domain must match the fully qualified domain name of the target Windows domain. Getting help with the SSSD configuration directives for the SSSD monitor, providers, and responders is straightforward once the man page naming format is understood. Most provider man pages are prefixed with SSSD _ followed by the provider abbreviation. Others are named after the daemon, configuration file, or module they represent. The concept of SSSD ID mapping should be discussed briefly as well. If the POSIX attributes for users are stored in Active Directory, minimally UIDs, GIDs, home directories, geckos fields, and default shells, ID mapping is not required. However, if they are not, ID mapping can be enabled to generate persistent values for those attributes dynamically. The SSSD ID mapping facility runs a static algorithm against Active Directory user and group SIDs to generate unique UID and GID values across the domain. And because this method provides unique UID and GID values, they will be persistent across all Linux servers authenticating against the domain. System defaults for home directories and shells will be used unless otherwise configured. The default ID mapping setting for the LDAP provider is false, and user and group attributes are stored in our Active Directory server. So, for our example, no ID mapping configuration changes are required. Finally, we will implement the configuration file for the SSSD client itself, which is the etc SSSD SSSD.conf file. It's important to know that if you compose this file yourself, the permissions must be set to 600 so that it is only read and writable by user root. If the permissions are not set this way, the daemon will fail to start. So I've prepared several example files we're going to go through directive by directive, so let's begin. So we'll start with the default YAST generated configuration file. And as you can see, there's a lot of information in it and not a lot of configuration. YAST does not generate a very tidy configuration file, and I do like a very tidy configuration file. So let's go to the next example, which is the same configuration file, which has been tidied up. So first of all, note the services directive. This is where we're telling the SSSD which responders to invoke. So in this case, we're simply using the NSS and the PAM responders. The domain directive specifies the SSSD authentication domains that this daemon is going to serve. We only have one, and it's set to default, which is just a name that YAST gives it. The configuration stanza for the NSS responder has a reconnection retry. Since the responder is a child process of the monitor, this directive states how many times the monitor will restart the responder if it crashes. And the filter directives allow you to filter out local users that the SSSD should not return in a search. This is just a lab example, so we're just showing root as an example, but in an operational environment, you of course would want to filter more. The PAM responder has a similar relationship to the NSS responder configuration. And that takes us finally to our domain configuration. And notice that the name of our domain matches the domain name which is specified. Oops, I'm sorry about that. For the domain directive. This is a necessity. So, enumeration is set to false. Essentially, if enumeration is set to true, the daemon will attempt to cache everything in the directory that it can read. Now, if you have a small directory, this could actually be a performance improvement technique. However, if you have a large directory, if you have tens of thousands, hundreds of thousands, or millions of objects in your directory, it's not hard to understand how this could be a performance inhibitor. So my default is to always set enumeration to false and put the daemon in basically a cache on query mode, which takes us to caching. Setting cache credentials to true enables the feature that will allow your users to log onto the Linux server if your authentication source goes offline. This is one of the most useful features of this daemon, and I always turn it on. Here we are simply specifying the LDAP provider is going to be used to look up user IDs, and the authentication provider is going to be set to Kerberos because we're authenticating against Active Directory using Kerberos. And to help locate our Kerberos environment, we're specifying a couple of basic Kerberos directives. We're specifying our LDAP URI and our search base to start looking for users. Our schema is set to an RFC, which is a standard RFC variant. We'll talk about that more in just a moment. And since Windows always prefers uppercase realm names and we're talking to an Active Directory backend, I've set the force uppercase realm to true. Here we are specifying our GSS API authentication credentials. Notice we're using our computer object. And finally, well, next to finally, since Active Directory does not use standard POSIX attributes, we have to map standard LDAP attributes which are present in the RFC specified to their Active Directory equivalents. So in order to use this system, we minimally have to map these attributes. If you're using more attributes, you can see where the mapping configuration can get a little more complicated. And finally, we have a debug level directive, which currently is disabled, and I turn it on when I'm having issues with the daemon itself that I need to troubleshoot. Now, your debug level actually ranges between 0 and 9, with 9 being the greatest, but I find I never have to set it above 7. Levels 8 and 9 give more programmatic information that is not really meaningful to system administrators. And essentially, one of the best features of the SSSD is its elegant logging. Usually when I'm having trouble with the daemon and I turn on the debug logging, I find what is wrong with the daemon in very plain English at the end of the log file, and it makes solving problems extremely simple. I cannot speak well enough about it. So let's look at our next example. So what's different in this configuration file is our authentication domain has been changed to match the fully qualified name of our Windows domain. And that is once again because we are using the Kerberos provider, as explained before. And notice that our domain tag for the stanza has been changed to match our domain. Notice also we have set a case-sensitive directive to false. The case sensitivity mode for the LDAP provider defaults to true. And depending on the file systems you're using or the naming standards you have in your Active Directory environment, this could impose some usability issues, so I generally always set it to false. And notice that we've basically re-implemented our krb5.conf file in our sssd.conf file, and this just tunes the Kerberos communication for the daemon a little bit, and I always do it in my production environments. Notice as well that the LDAP schema has been set to AD. This is one of the most valuable features of this daemon. When you set the schema to AD, the daemon natively understands the Active Directory schema. And what that means is you no longer have to do mapping, you no longer have to do attribute mapping in order to connect and use the system. It's really fantastic. And we've also added user and group search bases. Now for our example, it's not really meaningful because they're both set to the same thing and we're using a very small lab system. But if you had a large system with large enumerations of objects, it might be beneficial to you from a performance point of view to set different user and search bases, user and group search bases. And on to our next example. And basically, the only thing we have changed here is we have added an override homedir directive. So this directive will override whatever path I have specified in the value for the homedir attribute. And I generally prefer to have a different home directory path for my Active Directory users than for my local users. And this override directive will create a subdirectory for the domain and then a subdirectory for the user. And we'll see how that works in just a moment. Onto our well, let's go ahead and make that home directory path before I forget. There we go. And our final configuration file example. Something else to notice is we have set a DNS discovery domain directive. And notice it's equal to the fully qualified name of our Windows domain. So we actually do not have to do this for our configuration because our Linux server is participating in the same namespace as our Windows domain. However, when I mentioned earlier that the Linux server could exist in a different DNS domain than the Windows server, but you could still utilize the service location facilities of the Active Directory domain, this is where you would configure that. So basically you would simply set the DNS discovery domain to the fully qualified domain of the Active Directory instance you wanted to use for Windows Service Discovery. Very handy. And we also have the addition of an access provider. So yet another provider has been brought to bear. It's important to understand when you enable the access provider, if you do not specify access provider criteria, then all access to the server is disabled by default. So let's look at our access criteria. We have set the LDAP access order to use an LDAP filter and an expiration policy. The expiration policy to use is the Active Directory expiration policy, yet another benefit of setting the schema to AD, because those native expiration policies are now understood by the daemon. And a pretty standard LDAP access filter, which says if a user is a member of this group, the darkvixen240_G group, they will be able to log into the server. If not, obviously, they will not. So let's go ahead and put that configuration file into place. There we go. We'll just copy it over. And then we will start the daemon. Fantastic, the daemon started. So let's see if we can look up some users, some Active Directory users specifically. Fantastic. We absolutely can. We're reading all the attributes we need to, and notice that our home directory path honors what we set in the override directive in our sssd.conf. Fantastic. Let's just look up another user. Fantastic. Same results. So let's check the group membership for these users and see if we can use them to test our login and our access control for our Linux server. So we will actually use the net utility for that, and since we're using the net utility, we will have to instantiate a Kerberos connection outside of the SSSD. Using the security of our computer object once again. And this should work. So let's start with Ming. So we're just doing a standard net search for the SAM account name attribute, and we're just going to grep for the member as we would with a standard LDAP search. Very good. We see that Ming is in fact a member of the darkvixen 240 group. Let's check Lin. And we see that Ming is a member of the darkvixen 230 group. So these two users will be a good test. So let's try this out. And we'll try Ming first. There we go. And fantastic, we were able to log in and notice that our home directory path was created as we intended. Fantastic. Let's try to log in as Lin. In fact, access was denied. So it looks like our configuration is working extremely well. Before we forget, let's make sure that we check config our daemon on. That way it will start the next time the server boots. Fantastic. So we now have a well-prepared system not only for operational use against Active Directory, but for issue assessment if failures occur. I hope you've enjoyed this tutorial, and I hope you've learned quite a bit. If you want to learn more about me, my articles and presentations about the SSSD, please visit my website address, which is on the slide. Look for more video tutorials on entry-level and advanced SSSD topics coming soon. Thanks, and have a good one. Cheers!